Hey everyone, and welcome back to the channel. If you've been following along in our multi-tenant CRM series, you know we've been building out a full application step by step. In our previous video, we covered getting access tokens working to handle user authentication in our project. Now, access tokens are great, but they expire, right? And you don't want users having to log in again every single time. So in this video, we're going to complete that authentication setup by adding refresh tokens to our project. In this episode, we're going to tackle some really important stuff. We're going to make our authentication even better, add more to the user profile, and fix a little visual bug thanks to some awesome feedback from you guys. First off, we need to add some new properties to our user model specifically for handling the refresh token, and then get our database updated to support that. Next, we're going to do a bit of refactoring on our existing login process and the code for getting the user profile. This will just make things cleaner and ready for our next step. Then comes the big one for authentication. We're going to implement the refresh token logic. This is crucial for keeping users logged in smoothly. As part of that, we'll need to create a custom HttpClient handler. This little piece of code will automatically take care of adding our tokens to requests and handling the refresh process behind the scenes. After that, we'll jump back to the user profile page and add that description field we talked about earlier, doing any necessary refactoring around that feature. And finally, a huge shout out to one of the viewers. They left a comment pointing out a flicker issue when switching languages in dark mode. They were totally right. Great catch. We're gonna fix that visual glitch right here in this episode. Pretty packed episode, right? Alright, let's dive in and get started. So as a first step, I'm gonna add a few new fields to the users table. Since we're using code first, we always start by updating our model, and that's exactly what I'm doing right now. Later on, we're going to generate a new migration and finally update the database to reflect these changes. So first up, refresh token. This one's for storing the refresh token itself. Pretty straightforward. We just need a place to save the token. Then we have refresh token expiry time. This is going to keep track of when the refresh token actually expires. Because, yeah, tokens shouldn't last forever, right? Now this one, attempt count. This is kind of a safety thing. I'm going to use it to limit how many times someone can try to use a bad or expired token. Helps protect the app from abuse. And finally, I'm adding this property called row version. What is it? Well, it's basically a concurrency token used by Entity Framework. It's a special field that helps Entity Framework detect if someone else has modified the same row since it was last read. So, if the data has changed in the meantime, Entity Framework throws something called a DB update concurrency exception, and your update gets rejected. That's actually a good thing, because it protects us from accidentally overwriting someone else's changes. Now, to be honest, for simple apps or single-user scenarios, you usually don't need this. But for more advanced apps, like ours, where many users or services might try to update things at the same time, it gives us an extra layer of safety. Think of stuff like updating refresh tokens, user data, or anything that really matters. And since this is going to be a multi-tenant web app, kind of like a CRM, we want to build it in a way that's scalable, secure, and maintainable from the start. So yeah, row version might feel a bit unnecessary right now, but later, when we add logging and see real-world scenarios, it's going to make a lot more sense. Don't worry, all the pieces are going to come together as we move forward. I'm setting the API project as the startup project. Now you might be wondering, why? Well, here's the thing. Whenever we run Entity Framework core commands like add migration or update database, Entity Framework needs to know how to build and run the application so it can figure out things like the DB context and the connection string. And that logic, especially the part that registers the DB context, is usually inside the program.cs file of the API project. So by setting the API as the startup project, we're basically telling Entity Framework, hey, use this project to bootstrap everything, find the DB context, and generate the migrations. Now, technically, we have both the web and API projects in this solution. And yeah, usually both of them are marked as startup projects during development. But for Entity Framework core tooling, it only works with one startup project at a time, and that project has to include the setup for your DB context. So that's why I'm switching it here, just to make sure Entity Framework has what it needs to run properly. Make sure the default project here in the Package Manager console is set to our Data Access project. Because this is the project where our DB context lives, and it's also where we want Entity Framework to generate the migration files, like the .cs files that describe the changes in our database schema. If we accidentally leave it set to another project, like the API or web, Entity Framework Core won't know where to put those migration files, and it'll either throw an error or drop them in the wrong place. So to keep things clean and organized, always point the default project to the one that contains your DB context and migrations folder. In our case, that's data access. Just a small step, but it saves a lot of confusion later on. Alright, here we go. Time to add our database migration. The command is add migration, and then we need to give it a name. For this one, since we're adding the refresh token properties, we'll call it add refresh token. When you're naming your migration, start the name with a capital letter, because migrations are actually C# classes, and by convention, class names in C# should always start with a capital letter. It's a small thing, but following naming conventions keeps your codebase clean and consistent, and it just feels more professional. Alright, as always, we're going to check our migration class first, just to make sure everything looks good and there's nothing weird in here. So in the up method, we're adding 4 columns to our users table. The refresh token, this will be a nullable string with max length 128 characters. Then we've got refresh token attempt count, a tinyint to track how many times someone's tried refreshing. Next is refresh token expiry as date time type and row version. And down here in the down method, this is our undo button. If we need to roll back, it'll clean up all these columns we just added. I really want to encourage you to play around with migrations. Try adding them, reverting back one step, or even rolling back multiple migrations at once. Now here's the thing. You might hit some snags at first, and that's totally normal. But trust me, working through those issues is exactly what's going to level up your skills. The more you practice this dance of add migration and update database, the more comfortable you'll get. Before you know it, you'll be handling migrations like a true pro. Okay, it looks fine to me. Now I'm going to run the database update command to apply these changes we just made to our user table. Alright, let's check our database to see if everything updated correctly. I'm seeing some red squiggly lines under our new columns. No need to panic though. This usually just means our database view needs to refresh, since we had it open during the migration. Let's scroll to the end of the table columns. And yes, there they are. All our new columns added perfectly. Refresh token attempt count, and the others we just implemented. Alright, now that we've verified our database columns are properly set up, let's start with API project to add something new. I'm going to add a new endpoint to our user controller for getting profile data. We'll need this for the user profile page. Remember in our last episode, we made this an authorized controller, meaning every endpoint here is protected and needs a valid token to access. Now here's where we're changing our approach. Last time, we just sent all the user data back after login and stored it in local storage. But today we're going to refactor this to be more professional. Here's the new flow. After login, user gets both token and refresh token. When visiting profile page, they request profile data using their valid token. If token expires, that's where our refresh token magic kicks in. We'll dive deeper into that later. So we need to implement getUserProfile. And you'll notice it follows the same pattern as our other endpoints. Nothing fancy here. We've covered this structure before. Now the real work happens in our service layer. Let's jump over to the user service to implement getUserProfile properly. Okay, first, we grab our application user context. This gives us the user ID automatically thanks to our authorization. We do a quick sanity check here, making sure the user ID actually exists. Then we use User Manager to find our user in the database. Throw an exception if user not found. Once we have the user, we transform it into a clean user profile view model. We never want to expose raw entity classes. Finally, we package everything up in our standard response model with the data property and return it. I'm using manual mapping here in the view model constructor for a really good reason. And actually, this is the same approach I take with all my entities in this project, both now and for anything we'll add later. The cool thing about doing it this way is everything is completely transparent. You can literally see each property being mapped right before your eyes. There's no hidden magic happening behind the scenes, no weird configuration files to maintain, and no magic strings that might break later. It's especially great when you're learning because you get to understand exactly how the data transforms from one shape to another. Now, for a project of our size where the mappings are pretty straightforward, this manual approach is actually perfect. With manual mapping, we get total control over every single conversion. The code stays super readable. We don't have to add any extra dependencies, and believe it or not, it's actually faster for simple mappings like these. If we ever get to a point where we're dealing with crazy complex mappings across dozens of entities, sure, we might reconsider. But for what we're building right now, having everything explicitly laid out like this gives us the perfect balance of clarity and control, and that's exactly what we want. Okay, let's move on. We need to update our interface to include this new profile method. Interface first, then implementation. It's a good rhythm to follow. There we go. It's fixed now. Let's make update and change password return response model too for consistency's sake. Right now we're just returning a boolean in the data property, but this way we're ready if we later need to show success messages on the page. Okay, now I'm going to refactor the login method. Instead of returning the view model, it's going to return an authentication tokens object. I actually created this model earlier before I started recording, so I'll update the method to use that. And I'll also change it in the interface so everything matches. Here I need to create the authentication tokens object with the right values. We already have the access token, but for the refresh token, we'll grab that from the token handler. Oh, I remember for this I already added the method signature to the interface. I had them commented out because of a build issue during migration. So I'll go ahead and uncomment those now, and we'll implement them in just a bit. So now during login, we're going to update a few fields in the user record, like refresh token attempt count, refresh token, and the expiry time. We save the refresh token so the client can send it later to get a new access token without logging in again. We store the refresh token expiry time to make sure the token doesn't live forever. We want it to expire after a certain amount of time for security. And this refresh token attempt count helps us track how many times someone has tried to use a refresh token. It's really useful if we want to limit the number of retries or detect suspicious activity. So all of this is about keeping the login flow smooth for the user, but also keeping it secure on the back end. And I just removed this one. It isn't really necessary, so we're keeping things clean and simple. Now let's take a look at the authentication controller. I remember there was an issue. So what's happening is the forgot password and reset password endpoints are supposed to return a bad request when something goes wrong in order to show the localized error message on the page, but instead, they're throwing a 500 internal server error, which is wrong. Same thing with the refresh token endpoint. So the refresh token endpoint takes in an authentication tokens object, and it returns a response model where the data property holds the updated authentication tokens. Pretty straightforward. We're wrapping the result so it's consistent with the rest of our responses. Here, if everything goes well, we return the response so that the front end can use the new tokens, both the access token and the refresh token, right away. We added these placeholder methods early on when we first set up our authentication service, but now that change password lives in user service, so I can remove it here. Also from the interface. Now I'm going to implement refresh token. This refresh token method securely generates new access tokens when the user's old one expires, so it gets authentication tokens. First, we validate both tokens exist. Then extract the user's email from the expired access token. Now this get principle, which we'll implement properly later, does the magic of extracting user information from our expired access token. It gives us back the user's principal, which contains all those important claims we originally put in the token, like the user's email address. This way, even though the token is expired, we can still verify who the user is before issuing them new tokens. This line grabs the user's email from the token's data, looks at all the user info claims in the token. If the user email value is null, it returns a helpful message. To keep the code dry, I create the token request failure method since I use it multiple times in the refresh token logic. The refresh token method doesn't return a Boolean. Instead, it returns a response model containing the authentication tokens in its data property. This method is async. Next, as Copilot suggested, I need to fetch the user using User Manager. If the user object is null, we'll return a clear error message by calling the token request failure method again. Here, we get the maximum allowed refresh token attempts from the token handler. When a user's attempt count meets or exceeds this limit, we do two critical things. First, we reset their refresh token attempts to 0. Second, we mark the user as inactive for security. During recording, I forgot to deactivate the user. I will fix it in a separate commit afterward. Okay, by next condition we validate the refresh token itself. The token can't be null. It must match the user's stored token, and the token must not be expired. If any of these checks fail, we increment the user's attempt count by 1 and update their record in the database. This helps us track and prevent brute force attacks. If we reach this point in the method, it means all security checks have passed successfully. Now we enter the token generation phase. First, we create a list of claims, including the user's ID and email, as core claims. Next, we generate both tokens, a fresh access token for immediate authentication, and a new refresh token for extended sessions. We then update the user's token properties, and finally persist these changes via User Manager. As you can see, I've placed the user update operation inside a try-catch block. Normally, I avoid using try-catch in the service layer to keep the code clean and structured. Well, about performance, try-catch itself is not slow. It's cheap unless an exception is actually thrown. The real cost occurs when an exception is thrown, because the CLR must build a stack trace, which takes time, and it interrupts normal control flow, causing extra processing. Exception handling often triggers additional operations like logging, which adds more overhead. And honestly, too many try-catch blocks can make code harder to read and maintain. But I added this one here to show how we handle concurrency exceptions specifically related to the row version column in our user table. Once we introduce a centralized logging mechanism, we can refactor this approach and handle errors more systematically. Alright, finally, we wrap everything in a clean response. We return a structured response model object containing the new authentication tokens. This completes our secure token refresh flow. Let's go for the second part. Before started recording, I made some small preparatory changes, mostly cleanup and minor refactoring, nothing that affects the core of the logic. I'll commit those changes along with our refresh token updates. Now in this part, we'll implement new methods in our token handler class. This method extracts user claims from an expired JWT. We configure validation rules here, checking issuer, audience, and secret key, but intentionally skip lifetime validation to allow expired tokens. The token handler decodes and verifies the token structure. If tampering is detected, we throw a security exception. We also enforce the correct encryption algorithm as an extra security measure against malformed tokens. Generate refresh token creates a cryptographically strong refresh token using .NET's secure random number generator. Here it allocates a byte array of size 64 to store random values. Uses random number generator.create, which is a cryptographically secure random number generator, and fills the byte array with random bytes using getBytes, ensuring strong randomness. Finally, the raw bytes are encoded to a URL-safe string for easy storage and transmission, and these simple getters centralize our token settings, ensuring consistency. Refresh token expiry days, and max allowed refresh attempts. I've already added these two settings to the token configuration model and also to the appsettings.json file. This is similar to how we added token expiry in the previous episode. Now that our token handler is complete, we'll shift focus to the web project. I'm upgrading our HTTP client registration in program.cs instead of a single-scoped HTTP client. I'm now setting up two named clients with add HTTP client, default client for regular API calls, and secure client for authenticated requests. We use these two different clients for API requests based on authorization needs. The secure client handles calls to secured controllers. Currently, user controller is our only authorized controller, but we plan to add more later. For all other requests targeting controllers that don't require authorization, we use the default client. We keep the same base address, but now have clear distinction for different use cases. Now, based on this change, I also need to update the HTTP client usage everywhere it appears, for example in the authentication service. First, I replace the raw HTTP client injection with iHTTP client factory for better client management. Inside the class, I create a ready-to-use HTTP client immediately initialized as our default client. Why default client instead of secure client? Well, because all methods in this service, they call an unsecured endpoint. As you can see, Visual Studio is flagging all our old HTTP calls. That's expected since we switched to the factory pattern. Let's update these one by one. I specifically named it differently to show you where we use this. Since we changed the login logic in the API and service layer, we need to make some changes here too. It must return response model with authentication tokens. Let's add a to-do comment here as a reminder to save the tokens to local storage. We'll get to that, but first, we need to do something else. And for the interface, I need to adjust the login implementation. That's it. Now I'm going to create a new class called Token Store. This will essentially be an in-memory store for our tokens. This way we can access them easily throughout our Blazor web application without fetching them from local storage. That's important because local storage isn't always available, especially when we're in pre-rendering mode. This class has 3 properties for the token data and a Boolean flag called isInitialized. This flag will be true when we successfully have both the access and refresh tokens. So that's the Token Store class for now. We'll add more functionality to it later in this episode, but this is sufficient for our current needs. Now let's create the refresh token handler. Here's a summary of what happens in this class. It calls the refresh token endpoint, and when it does, it sends the current access token and the refresh token. Since that endpoint is not secured, we use the default HTTP client for this call, not the one configured for secure requests. All the complex stuff, the actual API communication and service layer work, is handled by the code we wrote earlier in the episode. This handler just checks the result. If the call succeeds, we update our token store. If it fails, we return false. That's pretty much all it does. It's simple, isn't it? Now let's add some simple methods to the token store to handle interacting with local storage. A crucial point here is that I'm not injecting the JS runtime as a dependency into the token store itself. This design choice is specifically to prevent calling these local storage methods when the JS runtime isn't active, like during pre-rendering. This means that wherever you call one of these methods, you'll need to provide the JS runtime as an argument. Now, let's create another service. This one is for handling authenticated HTTP client requests. And I'd say this is really the core of our episode today, so it's quite important. Okay, when I first started on implementing the refresh token, my first approach was using a delegating handler with add HTTP message handler. The idea was to intercept outgoing HTTP requests and automatically attach the refresh token. However, I ran into quite a few problems with that approach. I had issues with local storage access during server pre-rendering, which was tricky. I also encountered frustrating scoping problems. For example, I'd fill the token store in one service, but then it seemed empty when accessed from within the delegating handler. But, since I was determined to store the tokens in local storage rather than cookies or session storage, I stuck with it. If you're unsure about the difference between local storage, session storage, and cookies, I'd recommend doing a quick search on those. So long story short, after wrestling with those issues, I eventually decided to implement the refresh token handler manually instead of using a delegating handler. This gave me full control, eliminated those weird dependency injection or HTTP handler errors I was seeing, and importantly, it works perfectly for our Blazor web app. Now, figuring all this out and making that switch did cause a bit of a delay in getting this episode ready. By the way, my implementation might not be the absolute best way to do it, but it works for our needs. If you know a better approach or have any suggestions to improve this code, please do share them in the comments. I'd truly appreciate any feedback. Okay, enough talking. Let's dig into it. We have an HTTP client created here, and this one is our secured client. We have 4 public methods, one for each common REST API request: get, post, put, and delete. For now, We're only using get and post in our web app, but the put and delete methods are included and ready for future use. So our public get and delete methods internally call a private method here called sendAsync. They simply pass a request to it. For our post and put requests, they delegate to a different private method, sendJSONAsync. This method handles sending data, so it requires both the URL and the object containing the data you want to send. For the get method, if the API call fails, we use the error handling service to get a localized error message, which this method then returns. This keeps our other services, like user service, clean and requires less code, avoiding repetitive error handling in each method. If the call is successful, then the response is deserialized into the desired model, and we return it. This overall approach, especially the centralized error handling and the use of a generic approach to deserialization, makes our code much cleaner. As for the post, put, and delete methods, their implementation is straightforward, so we don't need to go over them in detail. Let's move on to examine the sendAsync method. At the beginning of this sendAsync method, you'll see we explicitly make sure the token store is filled from local storage. The reason for this is a strange behavior I noticed. Changing the culture combo box can somehow cause the token store to become empty, leading to failed API calls like getting the user profile. So this check ensures we always have the tokens before trying to make a secured request. We've wrapped this in a try-catch block. If anything unexpected happens, the catch block will trigger, clearing the token store and sending the user back to the login page to re-authenticate. There are two if statements we check here. The first handles if the access token has expired, and the second catches responses like unauthorized or forbidden. Now, it feels like maybe checking for expiration explicitly isn't always necessary, or perhaps these two conditions could be simplified into one check. I'd love to hear your thoughts on this in the comments. If the current token in our store is out of date, we first request new tokens through the refresh token handler. Once we have them, we update them in both local storage and the in-memory token store. Finally, we send the original request to the API, but before sending, we call add authorization header to add the new access token to the request header. If we get an unauthorized 401 or forbidden 403 as the response here, it usually means our token is bad. After refreshing the tokens, we need to retry the original request. However, there's a catch when retrying. You can't just resend the exact same request object if it has HTTP content, like for post or put, because the content stream gets read the first time the second request will go without body. This would cause an exception on retry. To fix this, we create a copy of the original request before we send it the first time. That way, we have a clean copy ready to be sent again if a retry is needed. SendJSONAsync is very similar to the getAsync method. The main difference is that it sets the request content as JSON based on the generic data object passed in, and then we have the add authorization header async method. As I mentioned earlier, its job is simply to set the token on the request header. Now, if you remember back in episode 5, when we were fetching the user profile, we set the authorization header there directly by getting the token from the view model stored in local storage. And finally, we have clone request method. What this does is create a completely new HTTP request message. It starts by creating the new request object with the same HTTP method and URI as the original. Crucially, it copies the content to the cloned request, ensuring the body is available for rereading later. It also preserves the HTTP version settings. Then, it iterates over all the original request headers and adds them to the cloned request, using triad without validation to add each header without strict validation during the copy process. I highly recommend you debug this class yourself. It's the best way to figure out what's going on and understand exactly how it works with a refresh token logic and handles sending HTTP requests. I want to show you something quickly in the error handling service. I've added another method overload there. This one allows us to pass in our response model instead of the raw HTTP response message. And this is the specific overload I used in the authenticated HTTP client service. Okay, now it's time to add our new classes to the dependency injection container inside program.cs. Now I'd like to show you the magic of our new implementation in the user service. We can remove all those individual injected services from this class and just replace them with the authenticated HTTP client service. The getUserProfile async method must return a response model with the appropriate view model exactly the same as the service layer. And here's the nice part. All these lines of code we had before can be replaced by just one line. The same simplification happens for the update and change password methods. That's clean and nice, isn't it? Now that we've updated the service class, we also need to update its interface. Now, before finalizing this step, let's complete the to-do task we had in the login method. Remember? It's simple now. After a successful login, we put the tokens into the token store and also save them in local storage. Because we're using the token store here, we necessarily need to inject it into this class. Okay, now that's looking good. We've just completed a big milestone. Now let's move on to the next step. I hope you're still with me and not tired. Alright, in this next step, we're shifting our focus to the front end, working with our Blazor pages. We're going to start with the home page. You might remember back in one of the first episodes in this series, we put a simple test, API call on this page, just to show how to hit a public endpoint. Well, now that we've updated the HTTP client setup in program.cs, we need to adjust the code here. It's straightforward. We'll inject HttpClient factory now, instead of injecting HTTP client directly. Then we use that factory to get a client, specifically the one we configured as the default client, and use that to send our request. Moving on to the main layout.razor. Here, we only need to inject the token store. You'll see I also injected the navigation manager here, but that was a mistake during recording. I'll clean that up in a later commit, so just ignore that for the moment. Okay then, I'll add another Boolean variable called isInitialized to indicate whether this page has been initialized. We've used this same pattern on other pages before. We'll use this flag inside the onAfterRenderAsync method right after checking for first render. Inside there, we'll add logic to load the tokens from local storage into the token store, but only if the token store is currently empty. This step is particularly useful right when the application starts up, ensuring our in-memory store is populated if tokens exist in local storage. Moving on to the nav menu component, I've prepared the code for this and will paste it here now. In this code, you'll see I've changed the labels of the menu items to use localized text. Also, I've added an isAuthenticated Boolean variable, which is false by default. We'll use this flag to show different menu items based on whether the user is logged in or not. We'll come back to this nav menu later in the step to make it more dynamic. We'll add logic to update its state automatically based on the token store's isAuthenticated status. You'll also see I've included a logout link and a corresponding method. This method's job is simple: clear the tokens from local storage and then redirect the user. Now, where should it navigate? To the login page or maybe the home page? That's a design choice. It's up to you. Let me show you how to handle a tricky scenario. Suppose we want other components or pages to automatically update or run some code whenever the isAuthenticated state changes. We can achieve this by giving the isAuthenticated property a special setter. When the property is set, this setter will do something extra. Maybe it raises an event or calls a delegate to notify others. This means we need to modify the property definition here, and then in the components or pages that care about this state change, we'll add code to listen or subscribe. Now, let's go back to the nav menu component and add some code that I already prepared. Inside onInitialized, it subscribes to an event from the token store that we added earlier. This means that whenever the authentication state changes, the handle authentication state changed method will be triggered. OnInitialized is one of the lifecycle methods in Blazor components, remember? The handle authentication state changed method is our event handler. Here, it checks. If the user is not authenticated, it redirects them to the login page. It also updates the component's internal authentication state and ensures the UI updates based on the new state. And then we have the dispose method. It's called when the component is destroyed or removed. This method is for cleanup. Here, it unsubscribes from the onAuthentication state changed event to prevent memory leaks. Since we added cleanup logic in the dispose method, like unsubscribing from that event, it's recommended that the component implements iDisposable. Implementing iDisposable is the standard way Blazor knows that a component needs to be disposed of properly. So I'll add implements iDisposable to the component definition right here. This ensures that Blazor correctly calls our dispose method when the component is removed, making sure our cleanup logic runs. Now, the last page for this step is the userprofile.razor page. This page calls the getUserProfile method, which now returns our response model. So here in the page's code, we need to handle that response. We'll check the response's isSuccess property. If it's successful, we'll take the data from the data property of the response model and assign it to our view model. Otherwise, if isSuccess is false, we'll show an error message and then navigate the user to the login page. In this section, we're going to focus on adding a user description field to the user table. You might remember back in the previous sections, when I was creating the user profile page, I added some dummy text as a description just so the page wouldn't look too empty and would be somewhat closer to a real profile page. Now, we want to make that description dynamic, allow users to edit it, and have it actually stored in the database. Separately, we also need to rename a property. The activity property name doesn't really match what I want it to do, so I want to rename it to isActive. As you probably know, when you rename a property like this way, all its references get updated automatically, which is super convenient. Here we go. This is profile description. And again, since we're modifying the database schema by adding that description field and renaming the activity property, we'll need to create a new migration. Here's a best practice tip regarding migrations. Try to create separate migrations for unrelated sets of changes. For instance, I could technically combine these current changes, adding the description and renaming with database changes we made way back in the first step of this episode. While possible to put them in one migration, that's generally not the right thing to do. Instead, keep changes related to a specific feature or logical unit in their own migration. This practice is incredibly helpful if you ever need to revert changes, as it's much clearer what you're rolling back and helps avoid confusion. The default project for running migration commands should be set to our data access project. We've already discussed the reason for that. The project you actually run to start the application, the startup project, is still the API project. Okay, looks good. And update database. Now I'm going to add profile description to every model where it's needed, such as base input model. If you change is active like this, then it won't update its reference. You see, it didn't get updated. Another place we need to consider the isActive status is within the login method. A user might become inactive, for example, after too many invalid refresh token attempts. To enforce the rule that inactive users cannot log in, I'm adding this specific condition here. Okay, that's it. Pretty straightforward. Another key part, this time related to the profile description, is in the update method. Here, we simply check if the user actually provided a new description, and if so, we update it in the database. Okay, the rest looks good. Alright, so on the user profile page now, instead of that dummy text we had before, we're actually getting the description from the view model. The activity didn't change here. Okay, that's it. Now to give the user the ability to insert or edit their description, I'm going to add a text area. We'll put that in the Edit tab, just underneath where we have the date of birth. Okay, now it's perfect. Alright, so after the page is rendered, we need to make sure that new description input area isn't just blank. We'll populate it with the user's current description from the view model, just like we did for the other fields. After the data is saved successfully in the update method, what I'm going to do here is make sure the display tab immediately reflects those changes without needing a refresh. The way we do this is by taking the data we just saved and using it to update the view model's data. Now, there's a bit of a visual glitch we need to sort out. When you change the culture using that drop-down, if you're in dark mode, the screen briefly flashes to light mode before going back. It's a little jarring, and honestly, it just doesn't look good. So my goal in this small section is to show you how we can prevent that flicker. Alright, so to stop that flicker, here's the trick. In our app.razor file, which is kind of the main entry point, we set the body's visibility to hidden by default. This keeps everything hidden initially. And then, just to be absolutely sure, or maybe as a fallback, we apply that same hiding style in our main app.css as well. Alright, so after hiding it initially, how do we show the content when it's ready? In our main layout component, we add JavaScript interoperability, which allows us to call JavaScript functions from C#. In this case, it ensures the page's body is visible. Here I have to add an exclamation mark to make the opposite of his initialized value, which is false by default. Otherwise, the code inside the if block would never run, and that is not what I want. Okay, everything looks good to me. And that finishes this piece of functionality. Let's make a commit for it. I wanted to quickly mention that I usually commit after we complete a feature or a specific task like this. My goal is that seeing these smaller, incremental commits helps you follow the development process and how the code builds up, rather than just having one large commit at the end. Is showing the commit process beneficial, or would you prefer I skip that part most of the time? Drop a comment below and tell me what you think. So yeah, making a commit after every step is kind of a habit for me, but maybe you guys would actually prefer it if I didn't record every single commit in the video? Let me know your preference. Alright, time to see if everything works. To test our application properly, we need both the web frontend and the API backend running at the same time. You see, once we're logged in, we get back the refresh token and the access token. Now looking at the profile page here, you see that description input text area we added. I'm going to test the update process right now, and we'll be doing that using the access token we have. Perfect. The user profile is updated. And if I just pop back to the details view, awesome. The updated description is showing right here. See how it updated instantly? And if I change the culture now, perfect. It works as expected. Before, this was really annoying, because after switching the language, the app would just kick me out, log me out automatically. But that's all fixed now. It's behaving correctly. Also, as you can see, there is not any flicker after changing the language in dark mode. And yes, sign out works correctly. You can see the tokens are also deleted after we log out, which is exactly what we want. Now I'm going to show you the path the code takes when we need to refresh a token. It goes through the authenticated HttpClient service and then the refresh token handler. To make this easier to demo, I'm just going to temporarily set the token expiry to like 2 minutes. That forces the token to expire fast. And to actually see it happen, I'll drop a few breakpoints. We'll put one in the service, one here, and one more, say, around this line for the refresh token process. Alright, as you can see up here, the URL is the profile page because after a successful login, the user navigates right here. Okay, let's go through the code. Now we've landed in this send-to-sync method. First thing, it checks for a token. Since we have one, the isAuthenticated flag is true, as you can see. Then it checks if the token is expired. On this first go, it's not expired. So with a valid token, it makes the call to the API. And look, the response is okay, we see 200. And then it simply returns that successful response. So here in the user service, we take the deserialized response model, and inside the deserialized data, there's the user profile view model. Perfect. Everything looks fine here. Let's continue. Alright, I'm going to pause the recording here for a minute. This is just to let that access token expire. Then, I'll start it again, show you the refresh token process in action. Okay, we let that token expire. Let's go to the user profile page now. Cool, tokens expired, so we hit this if block. This is what we wanted. Inside the refresh handler, it uses the existing tokens to call the unsecured refresh endpoint. It uses the default HTTP client because the refresh endpoint isn't secured. We get a 200 response. Awesome. It then updates our token store with the new ones. Then, back in send-to-sync, it saves the new tokens to local storage via JavaScript and completes the original action. At this point, we're not in pre-rendering mode. This code is running client-side. But the refresh token handler itself might run during pre-rendering, which is server-side, and you don't have direct JavaScript access in that context. That is the reason we use the token store. Okay, so that was how the refresh token process works. We've covered a lot, and that brings us to the end of this episode. In the next episode, we're going to shift gears a little bit and dive into some other super important aspects of building a solid application. First up, we're going to implement centralized logging using middleware. This means we'll have one consistent way to capture important events happening throughout our application. Then, we'll get into where those logs go. We'll be using a popular logging library called Serilog, and we'll configure it to save all those logs directly into our database. This is super helpful for monitoring and debugging later. We're going to start adding unit tests to the project. Writing tests is crucial for ensuring our code works correctly and stays that way as we make changes. So lots of good stuff planned for the next one. If you don't want to miss that, make sure you're subscribed and have notifications turned on. Thanks so much for watching this episode, and I'll see you in the next one. Bye.